Okay, I think everyone can hear me, right? Okay, good, good, good. Yes, my name's Chris Lindop. I have been involved with IHE since 1999, I think, thereabouts. My first introduction to IHE was as a tester. I was working with GE on their MRI systems, and previous to me going to the MRI systems group, I was doing military integration, and that's one of the things that I always thought was missing in healthcare is the lack of interoperable standards and interoperability capabilities of healthcare. And that was when I first was introduced by, I don't know if anyone knows Charles Parizeau, but he was the individual who introduced it to me. This is like, this was my home. This is where I wanted to be, because it's all about getting the products working together. And it was, back in 1998, you could barely get the, barely get the systems even communicating together. Even getting DICOM, which is now a ubiquitous standard, to get the products to talk to each other was a very big challenge for that day. Since then, of course, I've been the IHE. I've been involved as a participant for Connectathons, and I've actually been co-chair for quite a bit, authored many of the profiles, including XDS-I, as well as one of the major revisions of XDS-I. It gives you a little bit of my background as well as other things. So when we come to this actual presentation, the level of detail, it's not advancing, I see that. Is always a challenge, because I've presented, and one of the things that I do want to present is really not focusing on, XDS-I has been around since 2005. Yep. Oh yeah, is it working now? Yeah. Okay. All right. And it's been evolving. And I do want to talk about some of the things that have. Is it? You can't advance it, but you can use the pointer. Oh, okay. All right. Okay. It's been evolving. But before I get to the standards, I thought at least to get everyone on the same page, we'll give a brief introduction of IHE and what it is. Okay. It's about standards and the economics of interoperability. What's important? Why do we care about standards? Number one, you want to essentially reduce your production costs. Why? Get people from stop trying to reinvent interoperability for every time they want to do an integration. Reduce the installation costs, reduce the schedule. And if you know exactly what needs to be implemented, if you've got a good plan in front of you, it goes much smoother. If everyone agrees upon which standards they're going to be using, that helps the projects going on. So it enables, and once you've done this, and especially when you get the vendors to especially agree on these interfaces, guess what? They're going to have more opportunity to work on better products for you. And that's the key thing. Reduce the cost for the integration, reduce the cost of time in doing projects, let the vendors focus on features and performance, and let clinicians focus on patient care. And of course, everyone knows that standards, they're not sufficient. They're necessary. They're foundational. They're very broad. That's a problem, actually. They become too broad, and interpretations become an issue. Yet some of them, they may not be narrowly focused. They may be very channelized. DICOM focuses on imaging. Well, what about the whole workflow that's associated with DICOM, with imaging? It's not there. So what is necessary is, is to really try to pull these things together. HL7 does great with workflow. Try to get the marriage of those different standards together and decide which standards to use is a key important element of what IHE does. IHE takes the standards, works as a group for users, vendors, and you know, and the implementers to go define what it is that we want to solve, specify it out, and deploy it into e-health projects. Give you a little background of what IHE looks like. This is the organizational structure. There's the international board, which Vince has mentioned. He is the board member for Australia. Every deployment group around the world has a representative to that board. The deployment group is responsible for understanding what the issues are for your community, for your local, for your region. The development groups, radiology, cardiology, all the different various development groups, their goal is to really get down to the technical nuts and bolts of how to satisfy the user requirements from a global perspective. And as Dee Dee was mentioning, yes, their framework is based on IHE profiles, but they may have to do additional add-on features to make them work. That responsibility becomes part of what is in the regional deployments group venue. You're going to look at a profile. You're going to say, yes, XDS-I works for us. We want to use it. But what is it not doing for us in just its entirety? Maybe we have to add a few things to it. Maybe we have to define some content that has to go with it as well. That's the roles of what the deployment group is. But it's not just defining the content. Now we also have to take it to the next level, the testing of it. We want to make sure that what we want to be implemented can be deployed, can be tested. That's the role of the regional groups. That's what we do in Australia. So it's driven by the professional societies and the contributing vendors and the participating vendors all getting together to help define an interoperable framework and an eco environment for healthcare. The key to what the profiles do is defined in a technical framework. It provides the use cases. It provides the specific requirements and flows. That's what you find in the technical framework. Very detailed oriented. So you don't have to necessarily repeat that again. And then the other part of it, and this is one of the key important elements of what one should be doing locally, is the connect-a-thon. It's usually a week-long event. You get all the vendors together. We have the specifications. We have the testing capabilities. We have a testing framework, test tools, and we get at it. We get and test these products, make sure they're deployable. Not only for Australia, but if you test for an IHE profile, it's deployable anywhere in the world. And those are some of the key things that you would want to be able to do. And it is a challenge. It really is a connect-a-thon. Testing all of the players in 1 week, one location, and doing it basically not at an install. Process starts off with doing proposals. It's a yearly cycle. You create the profile. You define what your problem is. I'm submitting a proposal right now to do AI workflow as an example. The committees will come together. They'll choose which profiles they want to work on. Create a draft of it, publish it for public comment, get it out there for trial implementation, take them to the connect-a-thons, and then demonstrate it too. Demonstrate the interoperability. Once you've done it at a connect-a-thon, now you can take what you've done at a connect-a-thon, bring it to an organizational event like HIT, and do a demonstration publicly. We've done that in the past here, and then you'll see that it's ready to be bubble wrapped and sent to be interoperable products out into the clinical settings around the world. So that's basically in a nutshell what IHE is all about. And so I did want to make sure everyone gets on the same page. Radiology, this is the one that is near and dear to my heart because I was a co-chair for over 10 years with them, and certainly have done many of the profiles for that group, for the group. It's really focuses on imaging, radiology systems. How do we get them to do the data flow, the workflow? How do you present images on a display? What kind of content should be in there? These are the things that radiology, the radiology work, the group works on. Our sponsors, our primary sponsor is RSNA in North America, but internationally, we've received, we get support from groups like Ransford and other groups around the world, even in Europe and so on and so forth. IHE Profile has been tested and implemented by hundreds of companies and around 25 plus countries around the world. It's probably even more than that today. So that's it for my basic intro to what is IHE. And now I'm going to talk a little bit about clinical imaging. And I'm going to start off with some of the newer profiles that we've been working on in IHE, the encounter-based imaging workflow. Encounter-based imaging workflow, many of you probably know what that is, but if you go to what do we know today, most of what we're working on today is order-based. You get an order, you schedule it, you place the order, you schedule it, and you acquire it, and go through a very standardized process of workflow with images and reports, all the way through billing. But this model doesn't necessarily work for everyone. Who doesn't it work for? Something as simple as, it's not simple, it's something as basic as photos and videos. Someone taking a picture of a rash. What do you do with that? How do you annotate that? What kind of information do you need to be putting it together? That's one area. The other one may be even ultrasounds, point of care ultrasounds. That's a big one. Ultrasounds are becoming very commonplace, almost as common as a stethoscope in many areas, because there's the portable ultrasound, the mobile ultrasound is getting so small in the handheld. You'll likely see them almost as an app that you can download from the App Store. And of course, endoscopic surgery, some of these other types of imaging, specialized imaging, which is not necessarily tied to radiology. Maybe they do DICOM, maybe they don't. But these are some of the things that you have to be prepared for with clinical imaging. I sort of jumped back and forth, but that at least gives you an idea of what framework we're working on. So when you're looking at clinical imaging documents, you'll have an image format, right? Image formats could be JPEG, they could be uncompressed videos, and they could be MPEG. They could be multiple other things. So what do you do with these? Well, you're going to have specific metadata that you'll want to be putting together with this, but you'll also want to be able to encapsulate it. Typically for us in radiology, we use DICOM. DICOM encapsulates the images. It goes through the workflow, which I just showed you quite well. The PACS takes it in. Well, that's not necessarily always the case, that you'll want to put your images in a PACS. Today, when someone takes a picture of a lesion, maybe they're going to annotate it. Maybe the only place they'll need to put it in is in the EMR. Okay, that's fine. There's nothing wrong with that. Well, how are you going to exchange it? No, it would be another issue. Once you've got it in there, how are you going to share that outside of the system? Well, oh, okay. Why don't I take a small break and ask questions? Anyone have any questions so far regarding? Okay, good. Very good. Since we have no questions right now urgently, then we'll continue. Mhm. Yeah. Oh, okay. Okay. All right. So DICOM becomes a major focus. That's all of our orders based is DICOM. Some of it, and actually it lends itself very nicely to point of care. But you don't have that front end. There is no order in encounter-based imaging. There's also the cases where maybe you don't even need DICOM. You've just got a picture. You can wrap it in a CDA, put it in a document storage device, but and share it with the standardized XDS. Nothing stops you from doing that. Many groups do that today. But you do need to have. When I say share it with XDS, you do need to have a method of keeping what? The metadata. What's the patient name? All date of birth, age. What's the encounter? Why are you doing this in the first place? Is there a procedure? Probably one of the key things that's important is the body part. What is this picture of? Where did you find this picture? You got a picture of the lesion. Is that the arm? Is that the leg? Give me a little bit more information because you'll need that. You'll need that. And getting that metadata straight is extremely important. And that's one of the things that we do as a group, define what the metadata is, getting it in the right places, and leveraging the standards that we've got. The XDS-I, the wrapped, you can wrap it in your image. If you don't want to go into the packs, that's fine. Or you can put it in DICOM, put it in your packs, and actually trigger workflow on it. I've got an ultrasound, and by the way, I think a radiologist should review this ultrasound and trigger that workflow, but not triggering it from one order, triggering it from the fact that you've captured an image, the real workflow that you've gone through. Okay, and so we've gone through this quite quickly. This is the orders-based imaging workflow. It's very DICOM centric. It's been around forever. Means as long as I've been working on, it's 1998, 1999, when we first started coming out of it. And the acquisition modality, this works, this almost there, you can't buy a MRI system, a CT system, an ultrasound system, well, a GI ultrasound system at least, that has this workflow associated with it. And then again, we've talked about the various different encounter-based imaging workflow, the use cases involve that. But this is where it really becomes tricky, because not everyone here has the same needs and requirements. But getting the metadata straight, understanding what that metadata is, encapsulating it appropriately. Is this appropriately encapsulated in DICOM, and I can send it off to my PACS or a specialty PACS? Or is this something that I just want to be able to wrap it into a CDA provided to my EMR or document management system and have it set there and trigger workflow flow from there? This is I don't have to get into this. I think we've discussed what image-based, encounter-based imaging workflow is. You essentially, patient's examined, uses some kind of device. He just wants to capture the encounter information, whether that is through, a transaction of actually pulling that information from your information system, or whether they actually manually put it in. Either way, you've got to get that encounter information. You capture the images, you add any other additional clinical information, and you store the images. The encounter-based imaging workflow for DICOM, which we've identified in IHE, and this is pretty solid as it can go. using existing standards in you know, an acquisition like a POC ultrasound system or endoscope or some other DICOM-based imaging device, you know, can use, you know, some of the existing infrastructure that we use today. And we're using, in this particular case, modality workless, pulling modality workless, but we've enhanced it such that, because in modality workless for the orders-based, there's a lot of orders-based information. In this particular case, it's encounters-based. So you will have essentially on your modality workless encounter-based information. So it is different, and one has to understand what the differences are. And these are specified in the IHE integration profile. Okay. Any questions on that particular part before we get into the XDS-I part? Yes. Oh, my God. Because we are going to switch a little bit. I've already covered two different fundamentals. And
thanks, Chris. Very, very good introduction. You mentioned about standards being sort of necessary but not sufficient to bring the whole thing about. So what are some of those other criteria in your experience that are important to bring the whole system together?
Okay, so there's a couple of things. Standards are, because of the fact that the standards may have gaps in them, number one, okay? You may have to be understanding what those gaps are. You have to be able to, and then once you've done that, you know, you have to be able to work with the standards organization to make sure they're filled in. But when you, but a standard in itself, and let's just take a step back, and we'll use DICOM as the example. It's great. It tells you, it could tell you quite a bit about how to do the workflow. It does, and here's an example right here. We want to get patient demographics into the DICOM image. Well, you know, okay, so we can do modality workless. We can pull information off from a RIS system. But how do you get that information in? Is that mappable? Do the two standards, how did they get the, you know, the patient demographics in their system in the first place? HL7 has their standard, okay? How do you get, but they may not map identical to what was done in DICOM. So yes, we have two different standards and they both work in their own domain. Now we have to have some way to get the two standards to interoperate. And that's one of the key things of why when I say there's, you know, they may not be sufficient because, you know, they don't really, the standards don't really interoperate. And that's one of the things an IHE will do is the mapping. How do we, you know, this is what IHL7 does, this is what DICOM, and I'm picking on these two standards because of course they're, you know, something that I'm quite familiar with, but there's other standards that you have the same issues. How do we get, you know, more of a universal language for them to talk about? And then we can do the mapping. You know, I think there's a lot of work that's done in PCC with the Rosetta Stone, trying to get a common, you know, a common nomenclature across the board. And that was probably one of the key issues is getting that nomenclature common. Any other questions? Yes.
I was just wondering how you go about getting over some of the challenges for more of your point of care, bedside type things, or the actual clinical images that are starting to be taken quite routinely within the dermatology setting or within the like wound care and wound management. How do you get around, have you encountered how to sort of address the challenge of the fact that metadata isn't readily available in that setting? It's quite often that you'll have a clinical image, it won't have like the ruler, it won't have the general things that you find with the general workflow that you see within the radiology department, and you know, the RIS, the modalities and the packs all talking to one another to give you that metadata on an image. Have you?
Okay, very good question. And how do we overcome that challenge? And there's one fundamental way of getting over that challenge, and it's called collaboration. And that means that, we have to get everyone to talk to each other.
Not my problem.
There you go. and, and, and that's where IHE and the integration profiles actually becomes, the first stop. I'm not saying this is the end stop. This is the first step. This is, hey, we've got this profile. We've identified the metadata. We think we know who should be providing it. You may not do it today, but this is where now we want to get the users involved, saying that, hey, this is a real problem. I want you to do that. And let's use this standard as a framework for going forward. Do those standards as a basis. Tell me why you can't do it. And we know you have the data. We know you have the patient demographics. We know you know what encounter this is. We know you know where the patient is. How come you can't tell us that information? Get that dialogue together and then test it. And as Dee Dee said earlier, we've got to be great proponents of testing. Test and test often, retest and retest and retest. Most important that these profiles, these standards are tested in a multi-vendor environment with user guidance. Okay. So collaboration is key. Thank you. Any other questions?
How do you close the order? What recommendations after that? Because the problem is that you work with some vendors force the close of the order, which is great. Then what I see being a customer is that the order is corrected and you don't know.
Well, it's a very good question. How do you close? Now we're going to talk about the orders-based workflow, and when closing the orders, when is an order really closed? And that's a very good question because it may change. And usually it's, how can you not close it until you've actually gotten a report? I mean, so it's got to be at the end of the cycle of the process. I mean, and that really is not really defined quite well in IHE because I just gave you my opinion. Someone else would say, I've done the technical part. As far as I'm concerned, it's closed. I want to be paid. and that's again, we're getting to the point where we've got to define the rules. We've got to do the collab. We've got to be. And sometimes when you're a provider, it's not, you come up with a consensus in your organization that says what is the closure of this study. Okay. I wish I had a better answer, but that's really the answer. I have to throw it back into your partner. Okay. And I definitely can give you my opinion. I've got lots of those. Any other questions? Okay. All right. So we'll move on to XDS-I. And in recent enhancements, the IHE integration profile, this has been around for quite some time, and it really defines image sharing. Whether it's between one enterprise, one hospital to the next hospital, to the physician's office. Radiology to radiology is a very important part of it. And key to that, what are the use cases that you look at? Retrieval of priors. That's probably one of the most important ones, but also consultation, second opinion. That's you've got images, you want to make sure that, you want to have, another specialty look at it outside of your domain, outside of your enterprise. And of course, teleradiology read. Of course, and the other part of it is getting those images back to the physicians. Who's your primary customer? Actually, your primary customer is the patient, but let's not go there at this moment. But because the imaging back to the the referring physician, get the images to surgical plan. Those are some of your key requirements that you're looking at. as we mentioned, there's this infrastructure called XDS, where it's cross-enterprise document sharing. It's great for your CDAs. It's great for, you know, a certain level of documentation, but it's not that great for imaging. Imaging is a little bit more of an expansive. You've got one image, you've got a multitude of images, all associated with the same study. Who works best with those type of images? Our PACS, our VNAs, DICOM. So what we've done to XDS is to put on an additional layer that says we want to do image exchange using DICOM. We do the top level with the XDS infrastructure. We identify what images, you know, that there's a study. We identified that the metadata associated with that study. You determine that this is what you want. Then you can do the retrieval, not from a main source, but from their point, their source. So it doesn't. So we're not creating another archive. We're making use of existing archives. Okay, and that's the whole infrastructure for XDS. That's a whole infrastructure for what XCA tries to do, not trying to make yet another source of data, but trying to make use of the existing data infrastructure that's out there today. So we've gone a long ways, and we've decided that a couple of things. Okay.
Yeah.
Well, well, anyways, I'm going to ignore this. One of the things is that we want to be able to add different references there that weren't there before. We forgot about a session number. That's a key thing in radiology. We want to add that into the enhancements, making sure that's in the infrastructure for the metadata that's out there in its entirety. A receiving system site, they may actually know the accession number. They want to pull that information off based on a accession number. Give them that capability. Give them a unique identifier for the accession, for the accession number creator, and give it a reference, give it the accession number, as well as the study instance UID, and provide that as part of the metadata for the imaging. Another part was, well, what happens when we want to delete something that's being shared, that was shared before? What if we've decided we've got the wrong images to the wrong patient, as an example? How do we fix that? You've got to have that capability. You can do that locally. Now you have to make sure that that information up in the registry is being taken care of as well. So this is our growing pains. We've got these, we have to add these additional features onto it, and that's some of the new enhancements, the recent enhancements that have been done. And that's the other thing that you get with IHE, is that it's not a stagnant process. It's a growing process. It gets feedback from where they are, where they are today to where we need to go tomorrow. And once you've got something deployed, you understand the limitations that you've got, bring it back in, fix it. Now everyone internationally has the same option capabilities. Oops. Okay. With that, we also wanted to look at how to manage, we talked about one of the primary use cases is getting external buyers. I want to be able to automate that process. How do I do that? Everyone has different nomenclature. Everyone has different capabilities, but I want to be able to pull this data in pretty much automatically. And once I get it in there, how do I convert it into a language that locally I can understand? And that's what this profile does. It's really what we would say it's an edge process. We've got the data out there. We've got the metadata that associates with it. But when you get into the nuts and bolts details of what's in that image, a lot of the nomenclature is localized for another enterprise. And how do we commonize that? And how do we import it into our system? is what this profile does. So, and this, yeah, this is, some of the issues that we've just talked about that I just mentioned. Want to be able to locate and access them in comparable views. One of the biggest issues that we want to make sure we don't do is we're not, re-imaging patients unnecessarily. I mean, that's a common problem. Making sure that we know what's out there, what that patient has had done before, being able to retrieve that information, being able to assess it ourselves in a rapid transition is important. So we developed this profile, and how we're doing with time, probably coming. Oh, that's good, that's fine. That's perfect, actually. So we've developed this profile and, to automate the discovery and import. And it's really targeted to hitting the installed base. It could be an XDS profile. This is what the profile looks like. Some of the details, based on the importer, you'll want to, who's pulling these images in. They'll want to be able to essentially do a scheduling of the data. They'll want to be able to find those, find the remotes, find those remotes that are associated with that schedule, retrieve them, find the external studies, retrieve them, and then store the priors. Not only just the priors, but also the reports as well. So this is what it looks like. I showed you the picture of what an IHE integration profile is. This is how you would see it inside the document. It doesn't require XDS, but it is, certainly XDS is one of its, main capabilities, but it can be used for, and that's one of the design criteria that's put on it. But we didn't want to we wanted to make sure that it was pretty much back-end agnostic. So, each site provides, retrieves priors for the other site and provides prior data. Yes, the import and the infrastructure can be centralized or implemented at each site. And that's an important feature. You could provide an importing service, or you just do that locally. And it leverages the existing profiles. And that's it. This is actually for my presentation later. But that's it for the clinical imaging.
Thanks, Chris. That's really good.
Yep.
A couple of minutes for questions. If anyone has a burning question, I'm not sure if you're allowed to ask questions. Okay, just one. Can you bring the microphone, please?
Yeah.
What? Sorry. You introduce yourself.
Todd Cooper. San Diego, America's finest city. Here in Melbourne, Australia's top town. That was my 2 minutes now. Just a very simple question. When you look at those importers, is there any idea of having like open source standardized components? Because I would think that if you took the top 10 different formats that they might be there, or is it really a mapping exercise for every installation that might use this?
That's a good question. It could be a mapping exercise.
Yes or no? I mean,
no, the answer is a maybe. Definite, solid maybe. There are times where we use CPT4 codes. I could use CPT4 codes. You could build a translator for that. Well, then there's also those which said, no, I created all my codes myself. I got the best codes. CPT4 was not good enough for me. So yes, the answer is definite maybe.
And the whole issue around codes and order codes is one that's actively being worked on in Australia, and Ranska are leading a process to try and get that sorted out. So it's certainly on our agenda. Yeah. So I mean, this is an example. The IDP profile is an example of IHE defining layers that go over the top of other implementations and specifications in the same way as the cross-community access layer does for documents. And so this is actually a new area for IHE, well, in this particular domain, but it's something that IHE has been doing now for a long time, enabling you to bring together a whole series of legacy systems that may or may not be standards-based themselves and based on other standards. So you can get a very heterogeneous system that actually interoperates, and that's what Didi was demonstrating. That system across the US involves hundreds of different underlying implementations, but with IHE providing a common layer over the top of that hides that complexity and allows a single query and lookup process to take place. And the IDP profile is a component of that kind of a capability that allows multiple systems to be brought together with a common view and access mechanism.
Okay.
So thanks, Chris. We'll have a break now.
A couple of questions.
I had another question. Sorry, didn't say it.
Chris, one question around imaging data, obviously very large data sets, and to support those use cases, they still need to be rapidly accessible, either for a radiologist or a referrer. So what sort of techniques does IHE support to make that happen? Or what sort of best practices have you seen in other regions to overcome those challenges when you need to move big data sets across wide regions and still have that happen very rapidly?
Yeah, no, that's a good question. There's a couple of things. Certainly, using web services is an approach to making sure those images are being, encapsulated and transferred as fast as possible. Using RESTful services as well is a possibility. There's different capabilities, and certainly the infrastructure. I mean, it doesn't matter how good of a technique you can do streaming. If you don't have an infrastructure to handle the streaming, it's not going to be very rapid. But when you look at, I don't have the picture, but the reason why, that's part of the reason why one keeps the images, in a location where, you don't want them to be in multiple locations. You just, give them a direct pipe directly to the source, not try to hop the images from one spot to the next, to try to make sure that that's as fast of a pipeline as you can.
A couple of other capabilities that go towards that is the ability to have a lower resolution, non-diagnostic image as part of the XDS, part of the IHE profile. So you can access those lower quality images if you're not doing diagnosis, if you're, say, a primary care physician or an emergency physician who just wants to get an idea of what the image looks like.
Yeah.
And the other thing is to be able to mark specific images like slices within an MRI or a CT study as the main images that you should look at. So you don't have to download the whole MRI study to actually see the diagnostic areas that are of interest. So there are a number of capabilities there that allow you to segment large sets of images into the areas that are actually of diagnostic interest.
Yeah, that's true. And that would be, selecting images for presentation as an example, where you would not take the full fidelity of the images. And that way you can do the transfer much more rapidly, or just getting basically the key images, the clip notes. There's certainly a report is important, but it depends on what you want to need for the images. If you're doing surgery, the report's not going to do much good. You need to see those images and so on and so forth. It depends on the actual use case.
It does. And of course, there's all sorts of compression techniques that are supported. But the manufacturers are also doing a huge amount of work in delivering that sort of capability. Siemens has some very sophisticated compression techniques that make that possible, and most of the other manufacturers are also doing that kind of work.
Yeah.
All right.